Rumpelstiltskin, Rumpelstiltskin. Hey, we're here looking at how moving charges are affected by a B field and how they feel forces from them. So we're going to look at Lorentz forces and Laplace forces here. Now, for a Lorentz force, this is if we have an electric charge, something like Q, and it's moving with a velocity v through a B field B, so a magnetic field. And we write that as F equals Q VXB. Well, remember, that's not an X, this is a cross product here. And if you haven't taken a look at the right-hand rule videos that we did previously, you need those right-hand rules, because if you don't have them, you're going to be so lost here, okay? So this is a cross product that we're talking about. So I'm going to write this out just so we can see how I would write it. These are all vectors. Notice how they're bold. So force is equal to some charge. This is actually a scalar right here. It's just going to modify that force value, make it larger or smaller. But then the velocity in B field, the magnetic field, these are vectors. So V cross B. This is what I have here. And this vector cross product here, it actually designates the direction of the force vector. And remember, that force vector will be orthogonal to both the velocity and the B field. It will be 90 degrees from both of them, so it will be in our third dimension. Okay? Be aware that if you have a negative charge here, whatever direction you got with your right-hand rule, you're just going to flip it. Okay, so if you did your right-hand rule and you're like, hey, it's a negative charge, you're just going to flip it. And that's because if you remember back to vectors, if this is some vector A, vector B is the exact same length, same magnitude, but just in the opposite direction. Okay, so you'll just flip it, left hand, you'll just flip it with your right hand in order to do that. Okay? Laplace forces are similar but different. We have a similar equation. A force is equal to a current multiplied by the length crossed with the B field. And what this is representing is kind of weird. While the current, we think current has a direction, where is it going in your circuit? What we really care about is where is it going in your circuit along a length. That we can give a vectorized direction to. So we're going to cross the length of the wire with the direction of the circuit in the current. And then we're going to cross that with the B field. Okay, this will tell us the direction of the forces. And what this represents is if I have a wire and that wire has a current moving through it and that wire with a current is in a B field, it will feel a force. That wire itself will feel a force pushing it in some direction. Okay, with this equation, we can actually see that Tesla, our units of B fields here, can be broken down. We can actually say that a Tesla is something similar to a Newton per amp second squared. That's just one way we could write it if we wanted it in more, closer to an SI term. Sorry, that's not right. SI terms, this has got to be a kilogram. That's going to be kilograms per amps times second squared in the denominator. Okay, so we really won't worry about that too much. It's just important to recognize that forces are still going to be in newtons, Teslas are B fields, lengths are going to be in things like meters, and currents are going to be in things like amps. Okay, now let's actually get into some of the nitty-gritty here. The nitty-gritty for these right-hand rules for both Lorentz forces and then for Laplace forces. So with the Lorentz force here, where we're saying F equals Q V cross B, remember that V is where your fingers go and then you curl them to the second vector. Okay, we've got 4 examples here, A, B, C, and D for this. A, B, C, D. 2 of them have negatives, the B and C. Pause this video for a second. Try to work through these A, B, C, and D with your right-hand rule knowledge and see if you can figure out the direction that these positive and negative charges are going to feel a force. Which way are they going to be pushed? And then after we unpause the video, we'll talk about it. But until then, pause. You should be paused at this moment. I'm literally just playing with my hair. So hopefully you don't see that and you're thinking hard and you're not distracted. What is that? What is that? Is that a bug? Ew, it's a bug. That was on my head. Oh, but you didn't see it because you were paused, right? What? You didn't pause it? You didn't try these out? You should pause and try these out. Okay, we're back. let's see, let's take a look at these. So here's our charge, it's positive. We put our 4 fingers in the direction of that charge. It's going like down a page or down my screen. And when I curl my fingers in the direction of the B field, my thumb is coming out of the screen or out of the page, depending on how you want to look at that. And since it's coming out, that's a circle with a dot. And if you're like, I didn't get that, I got left. Well, it can't be left or right because those are the directions that already exist. We're going to the right, its counterpart is left, so it can't be that. Can't be up or down because this must be orthogonal, so it has to be in or out. 50-50 shot, we get an out. The other way I like to think about it is I like to redraw these as that's my velocity and this is my B field. And I like to put them on some sort of pivot point. And now I can easily see that when I go through the smallest angle, V to B, my thumb's pointing out of my screen or out of my page, wherever I drew this, okay? When we try B, we've got our fingers going to the right. That B field's coming out of the page. Oh, I'm doing a chicken wing here. That means my thumb's pointing down. But this is a negative charge, so I need to flip it, and my thumb's now pointing up. So I actually have an answer of up on this second one, B here. Okay, so be very careful about that negative charge. Always messes a few people up. Okay, and if you can't get your arm over, try to really chicken wing it. For the third one here, our velocity is going to the left. The B field's going up, so if I just do a quick little redraw, I've got velocity going to the left, I've got B field going up. That's my curl. When I do that, I see that my thumb is pointing into my screen or into my page if I drew it beneath me. So that's in, but then it's negative again. So I flip it, and now we're coming out. So once again, we have something coming out. And last but not least, a positive charge. Thank goodness, no more flipping. The velocity is to the left, but the B field is going into the page. So I put my fingers going left, I curl them into the page, and I see my thumb is pointing down here, and it does not flip, so it's just down. Okay? And those are our 4 answers for this. Okay, just some simple right-hand rule stuff. You need to be able to do that. It's super, super, super important. Let's try this out for our other scenario here. If we're not doing this for the Lorentz force, we could be doing it for the Laplace force, which is that force is equal to the current multiplied by the cross of the length and the B field. For our first example here, we have a current going to the right direction. So we put our fingers in the direction of that current along that length, and then we curl them to the B field. So our fingers are going to the right, the B field's going up. I see my thumb is pointing out of the screen or out of the page, whatever it is. So it's coming out like that. For the next one, I see my fingers are going to the left here, so it cannot be left or right. The B field's going into the page because I see the arrows, so it can't be in or out. But when I go to the left, and then I curl my fingers into the page, I see my thumb is pointing down here, so I'm getting down as my answer, okay? Now if you're like, I got all these backwards, but I swear I'm doing this right. What hand are you using? Because if you're using your left hand, chop it off. Don't chop it off, but like, I don't know, stuck it in your sleeve or something like that. Get rid of it. Don't use this hand. Use your right hand for all these things, okay? So very, very important. And that's pretty much it in regards to that. What's that, LT Gray? That's not it? You'd like to... Oh, sidebar. Sidebar with LT Gray. Here's something from LT Gray. If you have a wire with a current in it, and you'd like to find the direction of the B field, here's a secret right-hand rule that you do for this. And it's not even really a secret, but we're talking about it now. Take your thumb and put your thumb along the wire, and then curl your fingers. And sometimes it helps to put your like pen or pencil here to do this, okay? When you do this, the direction your fingers are curling is the direction of the B field. So when I do this for my screen, I look at this and I say, hey, look, that's going to the left there. I'm going to curl my fingers around it. What I see is that when I'm kind of in front of the wire, so like kind of in front of the wire, like here's the wire, here's in front of it. When I'm in front of the wire, my B field's going down. When I'm behind the wire, my B field's going up. When I'm underneath the wire, I'm kind of going in. And when I'm above the wire, I'm kind of coming out. We can draw that like this. This is a circle here, okay? Or you could draw it as saying, look, on the top side, this is coming towards me. So it's coming out here and it's going in on the bottom. Both work. The key is if you're drawing this loop like that, note that you cross the line on the front because that's what you physically see. You see how it's crossed there, and then it's gapped in the back because we're going behind it in that direction. Okay, so that's how we can draw the B field if we know what the current is. In our examples we had here for the Lorentz and the Laplace forces, we didn't need to do that, but later on we might be asked to draw a B field, and that's just a cool way to do it. So thanks for that reminder, LT Gray. Super helpful, man. Okay, but with that now, that is it for right now. You should know how to use those Lorentz and Laplace forces. You should know how to use those right-hand rules for them, and you should take LT Gray's advice and know how to draw the B field if you've got a current carrying wire. Okay, so for that, the big cheese is coming soon. But for now, we're finished. Adios. Take it easy, everybody, and I'll see you later.